no air, hard vacuum. Those wheels will not survive under those conditions for 5 years, probably not even 5 months. They took quite a beating in the field demos. What we at Glenn Research Center took on was the task of recreating moon-capable wheels that had about 10 times the load capacity of the Apollo LRV wheels. And this actually, if you can't see this in the back, don't worry about it. This is actually intended to be a poster, or rather it works as a poster. But what it illustrates is all the things that we went through in order to recreate an exact replica of the very clever LRV wheels. Why would you do that? We needed a baseline. We wanted to have something to compare to when we did the next generation wheels, so that we actually knew that we were improving things. And that involved, yes, reverse engineering. We actually sent 2 young engineers to the Smithsonian to measure the physical properties of the original LRV wheels. We worked with the original manufacturer to recreate the manufacturing equipment that created the wire mesh, the bump stop that Ferenc talked about, and ended up creating, in fact, a whole set for testing. Now, unfortunately, some of these are going to be destructively tested, but we'll be learning quite a bit about just how well they did back before much computer simulation was even available. And you may recognize one of our previous speakers. So we recreated them for baseline testing. And pictured here is the simulated lunar operations lab at Glenn Research Center in Cleveland, which has not only a bed full of simulant, but as well a way of creating a controlled slope for climbing, so that when we measure just how much traction these things can generate, we can predict how steep a slope they'll make it up, and test that. So on to the next set of vehicles. One of the first things that we looked at was whether you could scale up the load capacity of the original Apollo type wire mesh wheel. And this wheel has 10 times the load capacity of the original LRV, Apollo LRV wheels. And unfortunately, that makes it so stiff, it might as well be, except for the weight, made out of solid metal. So this is not something that's going to give you a very smooth ride, well, even on city streets. We did a lot of testing with different ways of generating traction. And these are a set of wheels that generate, for a given load, about twice the traction of other types of wheels. But unfortunately, that's not something that at least I would ever send to the moon. And in working with the original creators of the Apollo LRV wheels, we came up with some interesting alternative designs where this actually is made out of a number of interwoven springs, which gives you increased load capacity as well as compliance, so that the end result is a wheel that has roughly 10 times the load capacity, is compliant, and lunar compatible, which, of course, we put to the test. This is a picture of a test with these wheels loaded to the level that they would see under the big rover, the LER, the Lunar Electric Rover, on the moon, which they survived. Actually, looking at it from this angle, it's hard to tell, but this is that same vehicle climbing that slope in the back of the lab. And these wheels actually outperformed even some conventional wheels. So, just to sum up, the lunar surface is challenging, very harsh environment, and it actually still has some unknowns for us. We're working on the concepts and in some cases even the hardware for a sustained human return to the moon. And as with many technology development programs, there are spin-offs potential out of these development efforts, so that, for instance, this spring wheel with a high load capacity actually has a number of potential applications here on Earth. If you put a bullet through it, it doesn't deflate. So it has military applications for getting troops home safely. It has potential for use in firefighting assistance vehicles. There are a number of places where you would like to have a high survivable wheel. And in fact, the fact that the springs return the energy to the vehicle when you decompress them, unlike the rubber sidewalls of the wheels on your car, this actually is a higher efficiency wheel than your traditional rubber tires. So there is a potential for making a high efficiency wheel, again, available for even ATVs and that type of application. So again, you may recognize one of the former speakers. At Glenn, in this technology development, we're trying to learn from those who went before in order to better create our future. That's it for me. Thank you for your attention.
Thank you to Phil Abel to show us a picture of the future. And as some of you may be driving home tonight in your Earth exploration vehicles, you can think about what has to be done if you want to make an exploration vehicle for another body. I'd like to remind you very quickly that there are going to be two more events going on with the lunar theme. First, at 7 o'clock tomorrow morning, from 7 till 8, right here in the Gein Science Hall and Rock Planetarium, we're going to have a special viewcast of the L-Cross lunar impact. That's at 7 a.m. here with coffee and moon rocks. Those are donut holes. They're going to be a little bit softer than those things that you saw up there on the screen. And then tomorrow at 3 o'clock in the afternoon, in the Natural Science Building in the main lecture hall, Ferenc Pavlic will continue by showing us a Discovery Channel documentary, which he consulted for with an informal question and answer session on the lunar rover. So I'd like to open up the floor to questions now for both of our speakers, Ferenc Pavlic and Phil Abel.
I didn't get the question right.
Are the Chinese on track to fulfill their timetable for exploring the moon?
Well, I certainly couldn't answer that question. Maybe Phil can.
It's a bit out of my area. I don't work